Swift frequency response analysis. Today's topic is response analysis via software. Presenter is me, that is Therapy. These are the timestamps of the video. You can pause the video and have a look. The equipment used is of Megger make and the model number is Frax 101. This equipment is used for Sfra testing. The associated software is Frax 2.7. It is available at the Megger website for free. Let us see how to download the Frax software. Type Megger Frax in Google. Click on the first link. This is the Frax webpage of Megger. Go down. Click on Product Support. This is the Frax software 2.7. Click on Download. This is the user guide. Obtaining a graph. You can watch my previous video to see how to obtain a graph using this equipment. Analysis basics. Analysis is always done between two graphs. Graph basics. The graph obtained is a body plot. On the x-axis we have magnitude in dB and on the y-axis we have frequency in hertz. The frequency varies from 20 Hz to 2 MHz. Let us see how the graph looks in the actual software. Type Frax. Then go to File, Load File, click on the desired transformer. We will have the transformer graphs on the left hand side and the magnitude, phase and phase plots on the right hand side. We will stick to magnitude plot. If you will click on the top X, all the graphs will get minimized. Suppose I want to see 1U, 1V and 1W, 1U graph. Then I will click on these two graphs only. These two graphs appeared on the magnitude plot. We can also change the color of these graphs from here. Right click and from here you can change the color of the graph. I will stick with red. This is the x-axis and this is the y-axis. On the x-axis we have magnitude in dB and on the y-axis we have frequency in hertz. The frequency range is from 20 Hz to 2 MHz. If you will click on graph 2, it will turn into linear scale, but the frequency range is from 200 kHz to 2 MHz. Graph 3 will have frequency range from 20 kHz to 200 kHz, and similarly it will keep on decreasing. Graph 4 will have from 2 kHz to 20 kHz, and graph 5 will have from 200 Hz to 2 kHz. So we will stick with graph 1. And since we are examining the body plot, this is the magnitude plot. We will also have a phase plot. This is the phase plot. And also we can see the magnitude and the phase plot together. We can also zoom into the plots to see the finer details. So this is the zoomed version. If we click here, we'll take the mouse cursor here. We can see the frequency and the magnitude. Similarly on the phase plot, here we can see the frequency and the phase in degree. Here also we have a logarithmic scale and a linear scale selection. Which frequency relates to which part of the transformer? The Sfra response is made from 20 Hz to 2 MHz. The overall frequency band is divided into several subbands. Now different parts of the transformer affect different frequency regions of the response. As you can see from the table, core affects frequency band that is less than 2 kHz. Winding of the transformer affects frequency band from 2 kHz to 400 kHz. Frequency above 400 kHz is affected by the tap winding and internal leads. This table was obtained from a blog post from Megger. I will attach this link in the description below. You can have a look. This is how a typical Sfra response looks. As you can see, there is a 0 Hz to 1 kHz region, a 1 kHz to 100 kHz region, then 100 to 600, 600 to 1 MHz, and then 1 MHz to 2 MHz region. Core plus windings affect this frequency region. Winding deformations affect this region, and taps and connection leads affect this region. One thing to note here is that the frequency demarcations are not rigid, but rather overlapping. Graph comparison methods. Three types of comparison methods are there: time-based comparison, sister transformer-based comparison, phase-based comparison. Time-based comparison. Same transformer response is taken at different time intervals and compared with each other. As you can see in this example, transformer A response was taken in the year 2000 and then in 2010 and compared with each other. This is the most preferred comparison method. Only problem is that factory SFRA test reports are not available every time. So next comparison methods are to be followed. Next we have sister transform based comparison. Two transformers are said to be sister transformers if they have same make, same month and year of manufacturing, same voltage level and vector group, same volt ampere rating, similar percentage impedance, and preferably adjacent serial numbers. If such transformers are present, then their respective responses can be compared with each other. But this comparison method is to be performed only when time-based comparison method cannot be done. Phase-based comparison. In this method, different phase SFRA responses are compared with each other. As you can see here, RY phase response is compared with YB phase response of the same transformer. Again, note here is that this method is to be performed only when neither previous SFRA response nor sister transformer is present. Confidence level of comparison methods. Since in time-based comparison, response of the same transformer is being compared, any deviation between the graphs suggests some changes inside the transformer. That is why the confidence level in this case is high. In sister transform based comparison, their responses should match, but slight deviation doesn't necessarily mean any change inside the transformer. That is why the confidence level is medium. In phase based comparison, different phase curves of the same transformer are compared with each other. In this case, outer phase curves generally match with each other, but the inner phase curve is slightly different in the lower frequency region. That is why the confidence level here is low. Low here doesn't mean comparison will not yield any result, but rather the results will be accompanied with further diagnosis. Two different analyzers are present in the Frax software. One is correlation analysis, another one is the DLT analyzer. Now, what is the goal of an analyzer? An analyzer takes two graphs as input, analyzes them in different frequency bands, and then determines the deviation between those two graphs within those bands. As said before, the Frax software has two different analyzers. The second one is the Chinese standard, and in the first one, any standard can be set by the user. Here you can use three different predetermined standards to analyze the responses. You can use the Chinese standard here again. You can also customize the frequency range according to your need. In correlation analysis, three pre-built standards are present which can be used to analyze the responses. Each standard has a frequency band in which the analysis is done. Cross correlation and DLT have the same frequency bands, whereas NC-PRI has a different frequency band. Each standard specifies the amount of deviation between the two input graphs within its frequency range. DLT analyzer is a Chinese standard that uses a statistical parameter known as relative factor to determine the deviation between the graphs. Here example values of R is given. If R is 1.82 between the frequency band 1 kHz to 100 kHz, then there is light distortion between the graphs within that frequency band. Similarly, we have different values of R for the frequency bands that will tell us the distortion between the graphs within those bands. We have seen three types of comparison methods. Now we are going to see two of them. First one is phase-based comparison method and second one is sister transform-based comparison method. So in phase-based comparison method, we need one transformer and several of its responses. So this is transformer 1 on the left hand side and several of its responses. We are going to see 1U 1V response and compare it with 1P 1W response. The red one is the 1U 1V and yellow one is the 1V 1W response. For comparison, we will go to configuration, then analyzers. We have two analyzers, correlation analysis and DLT analyzer. We can choose both or any one of them. I will choose both. Click on OK. Here on the top, we can see correlation analysis and on its right, we have DLT analysis. I will click on DLT. In DLT analysis, I can see a low frequency region, the orange one, a medium frequency region, the violet one, and a high frequency region, the light blue one. In DLT analysis, a relative factor value is obtained. In this low frequency region, the relative factor value is 1.82. Since this value is between 1 and 2, that the conclusion the software makes is that these two curves have light distortion between them in this frequency region, that is from 1 kHz to 100 kHz, that is the low frequency band. In medium frequency region, the value of relative factor is 2.42, which is normal. That means in this frequency region, both these curves do not deviate from each other much. In high frequency region, the value is 0.15, which is crossing the limit of 0.6. That is why this portion is highlighted. It is not normal. Then we can see other standards or other analyzers, that is correlation analysis. In correlation analysis, as I have mentioned before, there are three standards, pre-built standards. We can check them now. Go to configuration, analyzers, correlation analysis, go to settings, and here we have in statistical technique, we have three pre-built standards: cross correlation standard, DLT standard, which is the same Chinese standard, and then NCE PRI standard. Here NCE PRI standard is chosen. Click on OK. OK. So in NCE PRI standard, the frequency band that is studied is from 10 kilohertz to 700 kilohertz, and the value is 2.18, which suggests the normal deviation. That means both the red curve and the yellow curve do not deviate from each other much in this frequency band. If you want to study different frequency bands, we have to again go to configuration, analyzers, correlation analysis, settings, and we can choose cross correlation. Click on OK. OK. So here now in low frequency band, that is from 1 kilohertz to 100 kilohertz, the value is 0.9850, which lies between these values 0.9 to 0.99. That means a suspected distortion is seen between this frequency band 1 kilohertz to 100 kilohertz. In the medium frequency band, the value 0.9962 lies here. That means the deviation is normal in this frequency band. In the high frequency band, the value is less than 0.7488. That means here it is crossing the limits. Again go to configuration, analyzers, correlation analysis, settings, and we will go to DLT analysis. Click on OK. OK. When we come to DLT analysis, here the values 1.82, 2.42 and 0.15 are same as these values 1.82, 2.42 and 0.15. So this is basically DLT analysis in correlation analysis statistical technique. Now also we can add our custom frequency bands. To do so, go to again configuration, analyzers, settings, and here you can see a add functionality. Click on add. You can give a name to the frequency band. I will give low frequency. Let the minimum frequency be 100 Hz and the maximum frequency be 1 kilohertz, that is 1000 Hz. Let the normal value be 2, suspected value be between 1 to 2, and then click on OK. And I will choose statistical technique as DLT. Click on OK. OK. Here you can see a new green frequency band has appeared, which is from 100 Hz to 1 kilohertz. Here it is 100 Hz to 1 kilohertz, and the value is 0.90. This value is less than 1, which suggests obvious distortion. And from analyzing the graph itself, we can analyze that yellow graph is not matching with the red graph, and obvious distortion is present between these two graphs. Now we will see sister transform based comparison. For that we need another transformer. Go to file, load file, transformer 2. This is transformer 2 and this is transformer 1. How do we know that these two transformers are sister transformers? These are the nameplates of two transformers. Both transformer 1 and transformer 2 have same volt ampere rating, same voltage level, same make, that is Alstom, same month and year of manufacturing 10/2024, same vector group DYN11, same percentage impedance 6.45, and even adjacent serial numbers, that is 443 and 444. From these we conclude that these two transformers are sister transformers. For sister transform comparison, we will take one graph from transformer 1 and the same phase response from transformer 2. So 1U 1V response is taken from transformer 1, and similarly 1U 1V response from transformer 2 is taken for comparison. And we'll go to configuration, then analyzers, then I will click on OK. In the DLT analysis, that is the Chinese standard, We have low frequency band, relative factor value as 1.77. This suggests light distortion. Medium frequency band is 3.12. This suggests that the deviation is normal, that is no deviation. And high frequency band is 0.40, that is crossing the limit. In the medium frequency region, the value of relative factor is 3.12, which suggests normal deviation, that is no deviation. In the medium frequency region, we can visually inspect that both the red curve and the green curve are exactly matching each other, and that is what we are also getting from the analysis as well. Now we will go to correlation analysis. In correlation analysis, we had chosen DLT analysis, and also we had specified our custom frequency band, that is from 100 Hz to 1 kHz. In 100 Hz to 1 kHz, our value is 1.94, and from this value, the analyzer is showing suspected distortion. By visually inspecting, we can see that the green and the red are not matching each other. There is some distortion. So that is why it is telling suspected distortion. If we'll go to medium frequency region, the value is 3.12, and here it is saying normal, as we had found out in DLT analyzer. So we can also change the standard in correlation analysis. We'll go to configuration, analyzers, settings, and we can go from DLT to cross correlation. Click on OK. Then again OK. From 1 kHz to 100 kHz, we find that there is suspected distortion, that is in this region, low frequency region. In medium frequency region, from 100 kHz to 600 kHz, it is normal, exactly matching. And in the high frequency region, it is crossing the limits. Then we will go to last analysis, that is the NCEPRI. Click on OK. Again OK. Here the analysis is done from 10 kHz to 7 kHz. The value is 0.21. And in this region, visually inspecting, we can find that both the curves are exactly matching each other. And here also our analysis is telling that the deviation is minimal and the conclusion is normal. So this is how phase-based comparison and sister transform based comparison methods are done on a transform or sister transforms. Thank you.